Guys, he's going to talk about building event-driven architecture on AWS. So give him a warm applause and take it away.
Great. Okay, thank you very much, and good evening. Welcome to the talk that I'm going to give about building event-driven architectures on AWS. It will be less hands-on code, as you've seen with Oom's talk, but it's more about the architectural patterns of creating event-driven architectures, and also how you can do that on AWS. If you have any questions or things that you want to mention, please feel free to speak up. It's a small setting, so I think it's nice to have it engaging. So yeah, let's get started. So what we're going to talk about is 4 different steps in how your journey towards event-driven architectures can look like. So we start a bit like, okay, what is an event? What is that in the context of a domain? Later on, we're going to look a bit on how can you route events through your system? How does that work? How you can use AWS to do that as well. We also highlight a bit on, hey, if you have events and you want to store them, you want to make them more persistent. So what type of patterns and services you can use? And we're going to look at like, okay, how can you structure events and how we'll actually look at in a sort of, in a demo setting. So let's dive in the first part. So let's start with the domain. The term event. So what is basically an event? So actually an event is basically a signal that actually indicates the state that has been changed in the system. Usually events are immutable, meaning that they cannot be changed over time. It's something that actually happened. So it's also something that is described in the past tense. So like an order created, or invoice sent, or user logged out. So those are things that are happened in the past, and you cannot change the past. At least we don't know yet. But so they are immutable in a way. They're also lightweight. So they're like a message to actually propagate properties over business domains, actually saying what describing what they are. So things like IDs or details or things that actually happened and that are the truth for that. So that's the event is basically the truth of what has happened. And actually, if you look at companies and systems and building software, it's quite natural in this sense, because if you think about that, events in a business, that are things that are actually happening there. So, and it also tells something about the organization and how those systems are set up. So, for instance, if you have a company, there are different departments. There's the the retail department, the sales department. You have the fulfillment centers and the order picking. You have support. Those things are actually there, and there are all kinds of things happening in those departments. And basically, with the events, it's something that actually happens and that you tell your colleagues in other departments, basically. So, for instance, in the retail domain, you can say, hey, I've created an order. Well, the fulfillment center can say like, okay, I have picked the order, or I have shipped it towards a customer. Or in the support department, they say like, hey, I got a return requested. Someone is not happy with the order, and they actually want to send it back. And I have also received it. So those are things actually happening, and they are quite logical for the system that you are creating. Business domain itself, you can actually identify them as an bounded context, which is actually a logical separation between business units, and it actually gives meaning within that business unit. In a bounded context, it's important that you have like you talk about attributes. So for example, retail and fulfillment domains, they share like terminology about orders. But what actually makes an order is different in the retail domain than it is for a fulfillment domain. Because in the retail domain is someone that actually clicked and I want to have these with the order lines. And in the fulfillment is like, hey, I got these products, are they on stock? Those type of things. And who's actually picking them? What is my timelines for that? So they talk about the same thing, but in a different view, basically. And that's all defined by those bounded contexts. If we talk about events, we talk about so how are things orchestrated within those business domains. So in this example that you see, like, hey, there's an order that comes up in the retail domain, and that is actually handed to something like an orchestrator. And the orchestrator is a component inside that domain that's going to look like, hey, is this order in stock? So it will reach out to the event inventory manager. And that one says, yes, it's in stock. And the orchestrator says, okay, great. So let's reserve it and let's send an invoice. And then the invoice manager says, okay, here's the invoice. And it will actually be set back towards the to the outside component, like I've created an order now. So this is how you orchestrate your processes. Usually orchestration happens within domains. Choreography between events is something that will come back later. That's something that goes across domains. So in AWS, we have a service called AWS Steps Functions, which is basically like an orchestration workflow engine. Or actually, it's a state machine as a service. That's also how you can do it. And what it actually can do for you is actually make this orchestration across different components within this same bounded context, this domain. And you can do things like sequencing, error handling, retry, and actually listen for stage changes and act upon that. But it's actually pretty fixed, these type of orchestrations, these type of processes. And for a bounded context or for a domain, that's okay, right? Because we know everything that has to be happening for an order. But we actually not that much caring about what the outside world is doing with that. So, so let's take a look how this goes between domains. So if we're between domains, we want to do things like loose coupling. Because we don't want to depend on other bounded contexts as much in things that are changing, how they scale, how they're working. We want to focus on ourselves, right, within the domain. And there, we don't want to have like an orchestration component. We want to choreograph more the things. So we actually make things happening as they go by actually using events. So we want to get notified on certain events that has been taken place in this domains, and we want to react on that. For instance, like, hey, there's an order created that's public, and I want to know, like, please let me know when that order is actually shipped, because I can actually send it back to my customer or act upon that. So we look at like, what is the difference between choreography and orchestration? We actually use choreography to actually coordinate between microservices or bounded contexts. And it's actually something that you do with events and pub/sub mechanisms. So we have a service called Eventbrite. We come to that later in more in depth what it is. and SNS, which is like a pub/sub service to do that. But it's basically about, how do those publishers and subscribers act upon the things that are happening within my system. Well, orchestration is more like inside a microservice or in bounded context, where you're actually more orchestrating how the process flows, like we saw in the example with step functions. You can also see it a bit in the context of like API-driven architectures and event-driven architectures. I think if people talk about microservices, they actually start with, okay, we have service A, we have service B, and we want to decouple that from each other because we can scale them differently and they're less dependent on each other. But if you're expose those microservices using an API, you actually make a dependency to that service because suddenly you have to realize that the service can go down, that things are actually changing in that service. And usually we call them using commands or API calls, which are usually synchronous, meaning that you have to wait for the service to respond back. It should have an intent, something that I want to do, not something that happened, what we see with an event. And you have to direct it. You have to tell a certain service like, okay, now create an order or fulfill this thing. And like a command, things that you want to reach. Well, with an event-driven architecture, you actually do it a bit differently. So these events are asynchronous, meaning things are happening as they happen, and I get notified when the things are changing. It's a fact, so something has been happened. If you talk with an API, you want something to happen, and you don't know if it's happened. You have to wait for the response. But with an event, something has been happened, and you can act upon that. It happened in the past. Things are like account created or product added are like examples in there. So events are observable, not directed. So as an event producer, you don't have to know anything around your surroundings. You only have to know like, hey, this is the event, this is what I'll express and tell the people who are listening to that event to react. But I don't care how they react or even if they react. I just notify what actually happened in them. Usually I keep those things simple. It's like order created. It's like a mail has been sent. And actually, you can actually have other services consume those events without actually needed for me to actually have those changes. So I just telling what happens and those services are responsible for that. Well, as like direct commands, I need to know, like I have to direct to someone, say like, hey, please send an email confirmation. And then the notification service says, okay, it has been sent. So that's something that you direct to that. Observable events is like, okay, the customer has just ordered this. And maybe the notification says, oh, great, he has ordered this. So I will send an email to that person. So it's actually turning around the flow. Okay. So how can we actually route those events towards our system? So we now know we have our domains, we have our events played out, we know which services we want to create. So how do we actually make sure that events from service A will actually land in service B? So like I said, events are like asynchronous. You don't need to wait for the response to move on for the next step. So that actually improve resiliency and reduce dependencies. What we want with microservice, right? If my other service has issues, I'm not dependent on those issues. I just send out my events and that's it. Um, so, yeah, so what type of components do we actually have in event-driven architectures? So what type of tools do we have here? So one, we have like event routers, and those are like, yeah, abstract. It actually abstract the producer and consumer from each other, and they are actually, yeah, there for you to send events to as a publisher, and you can subscribe for events as like a subscriber, because we're actually, yeah, and the event router is actually making sure that those are that you are able to publish events to that, and for those that are subscribed for the events, that they actually receive them. Like I said, events usually are asynchronous, so that will improve the responsiveness and the less dependencies. And sometimes we also want to store the events. Normally, if like an event, you send it out, no one is listening to that, then yeah, you can just leave it there. But sometimes you also want to have that event be there as a fact that as soon someone, as another service listening to that they can still receive that. So you need to have stored that event in a state so that you can actually receive it eventually. And that's something like an Eventstore can do for you. And we're going to look at some examples later on how you can do that on AWS. So the next slide we're going to look like how does this type of event-driven architectures allow to scale and simplify like a growing e-commerce site. So let's start out with a simple service. We have a mobile app. We have a checkout service, right? On the website we say checkout, and we want to buy the things that are in our basket. And we have an order service, and we want that order service actually to process the order. So as soon as we say checkout, we want to do other things now. Our business is growing. People are actually liking what they're doing. So we get more fulfillment centers and things getting more complex. We also want to notify our consumers. And so we actually introduce different services there. So the checkout service, suddenly you have to orchestrate these calls around more services, like the order service, but also the fulfillment service and the notification service. So it is growing, it got more complex, and suddenly it's like, this team maintaining the checkout service, they get tasked to even implement more of them, make it a bit harder to scale out. So what happens if we actually make an event-driven architecture out of this? We can actually use a service called Amazon Eventbrite. Eventbrite is like a piece of infrastructure that you can deploy. It's running within AWS, is accessible by an API or using the console or using the SDKs. And Eventbrite task will actually be routing events from publishers. That can be either your own services, but it can also be AWS APIs and AWS services or third parties. And actually, what we now do is the checkout service will send out an event towards Eventbrite saying, hey, I have checked out this basket. For whoever who is interested to that, they can actually respond on that. So how does an event look like in Eventbrite? So we have like two sections that are important. One is the envelope, which actually contains all the metadata around the event. So usually it's the event ID, which version is it, which type of event is it, and where does it come from. So those are describing more the things around an event. So it's more used towards like the system and in the routing. And on the other end, we also have the payload, basically the information that is in the event that actually tells what is actually happening or has happened. Sorry, there's a question? We come to that later. If you look like SNS is like a pub/sub service. It was quite longer. If you compare together, I think they're quite similar in a way. They both, you can do some of those the same thing. But Eventbridge also integrates well with AWS services itself. So actually CloudWatch alarms, so things that are, yeah. So like my ECS autoscaling group decided to scale out. Those are like events coming from the autoscaling service. Those things are also integrated with Eventbridge. And there are also third parties, like if you have Salesforce, and I think there are a couple, I don't know if you have Jira. SaaS providers, indeed, they also putting events of their systems inside Eventbridge so they can respond on that. It's more like a glue between services, not only your custom service, but more the entire AWS ecosystem as well. Yeah. 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 Yeah, it depends more on your needs. You also mentioned like Kafka or, for instance, RabbitMQ can also do PubSub or even Redis. And so there are different systems that can basically do the same thing. But it depends on your needs, what type of SDKs, what type of languages, how do you want to integrate that you can choose which service you want to do. Yeah, yeah, have to check it. Yeah. You see also Eventbridge used for, it makes it also easier to do cross-region events. So if you go global on those type of things. So there's there are different capabilities if you compare it to SNS or to the other things. And it, yeah, like it depends. It's on my you say it a lot as architect, but yeah, it depends on your needs, what type of event infrastructure you want to use. So if you look at our example, we have our order created event. So the checkout service is now setting like, hey, I've created the order. It has usually it has a detail type, an event type, so that you can identify which type of event it is. Good practice is also to include a version. So over time, that if events are changing because of certain needs, that you can have like backward compatibility built in for events that are like on dead letter queues or anything like that. So, but that's versioning is something that is good to have as well, and it has a source so that you know where it comes from. So if someone has like also an order created, but from a different source, that you can at least filter on that. But yeah, we're actually pushing that towards Eventbridge. But we're actually, yeah. So you don't have to go to all those services and give them like, hey, I've created this order, I've created this order, I've created this order. Eventbrite is the one that does that in there. And actually, Eventbrite purpose is there to route the different events to the services that are interested in that. So like Ohm said, you can create a filter in there where you can say, as a subscriber, I'm only interested in the order created events. For instance, a notification service just wants to tell people that an order has been created. It isn't interested in all the other events that come there. Or the order picking, the fulfillment center. They only want to know orders that are created, not the orders that are left out or anything. So you can actually use those filters to route those events to the right services. And again, the checkout service is not aware of anything that is listening to that. It just states what happened. So let's say we now have a loyalty service, and instead of rewriting the application, changing the order service, we can actually now create this new service. We actually say to Eventbrite, okay, now filter all these events, and I want to have all the events which include a member, and once it has a member, then I can actually build out my loyalty program, because I can count how much orders that person did, or how well he paid his bills, or those type of things. So, meaning there's nothing telling the checkout service to do that. It's all then the responsibility of that loyalty service in there. And the only thing it had to do was just subscribe and filter the events that coming through the system. So to come a bit back to your question, so there are like different ways of using events within AWS. So we talked about Eventbrite, where you have event filtering, manage the scalable. It's like a service there. It's just accessed via an API. You don't have to provision any infrastructure to do that. We also have SQS. It's also used a lot with customers. It's more like a buffer. It's a queuing mechanism that you can do. It's durable, scalable, fully managed as well. And queues are usually in event-driven architecture. You want to have queues to handle back pressure. You want to make sure that the service listening towards those events, that they don't get overflooded if something happens, maybe due to a bug or due to a surge in demand, and that you can actually scale accordingly without losing events or without losing things around that. So queuings are a good mechanism to do that. Then we have SNS, like it looks a bit like Eventbrite, usually used for application integration. So if you build your own serverless application and you want to have a pub/sub mechanism, event-driven architecture, you can use SNS. You can also use Eventbrite, but Eventbrite is usually if you need more integration options. And if you want to orchestrate, usually within a domain, we can use step functions. So there's also a serverless solution. You create like a state machine, state management, and you actually can set the steps on how to come to certain processes. And those can result in sending out events to ID Eventbrite or SNS. So how does Eventbrite look under the hood? So on the left side, we have our different integrations, event sources. So that can be AWS services, like the example I gave with the autoscaling service, or it can also be Kubernetes, where there is a new version. Those type of events are also sent over, and you can respond to that through automation if you want. You can write your custom events, so for your own application and their own integrations. And like we said, you have like SaaS apps like Jira or any of those that are supported from our partners. And they actually send those events towards something called like an event bus. So that's like a stream of events where you can actually set the you can actually choose the places where those events land and where you want to respond on. For instance, if you want to filter them with rules, so you can say that you can put everything in one bus, but usually it's a common practice to also use different buses for different type of events because it also can help you with scaling. And you can have the different rules in there. So like the filter options that you set, either on an event type or maybe something inside the messages of the events. And the last part are like the targets. So those are the services that can actually receive those events. So that can be step functions, that can be SQS, it can be a Lambda function as your code. It can be like a container that just talk to the API or that's reachable over HTTP. So there are like countless of possibilities for you to actually design your system with this. Here we have an example of the event sources supported by Eventbrite. So like Zendesk, we have Datadog, OutZero, New Relic. I don't see Salesforce in. The Airflow, yeah. Airflow is more a service that collect the data out of Salesforce and can also send it back. So it's more like in data synchronization. It's less on the events, but we can take a look if you want. Something that Eventbrite has, which is also used, what can also be valuable for your solutions, is something called the schema registry. As like events can be anything, it's defined by the one sending out the event, right? And the consuming part want to know sometimes like, okay, what can I expect in an event? What type of data types? Is this always a string or an integer, or does it contain this field? Is it a complex type underneath? So those type of things, usually is, it depends on how the service is providing it. And with the schema registry, you can give it a bit of construct to that. So you can say, you can validate it in the registry if you want. You can also discover it and do code generation, what you see on the right side on that. So it actually is a good way for you to make some structure to those events inside that system. Yeah, so here are the different components. I've already talked a bit about SNS, like it's a simple, flexible pub-sub service. So actually, you push messages towards SNS, and it actually fans out towards different subscribers. One thing that SNS can do, it's not only HTTP calls or to SNS, SQS queues that you can send those events. You can also send it through email or to mobile phone pushings or text messages. So there's a different way of interacting. I think SNS was one of the first, SQS was one of the first services, of AWS. Yeah. Only if you subscribe to that, you receive it. So that's why usually you see the pattern where you have SNS with an SQSQ tied to that, because then those events become persistent and then you can retrieve them on your own pace. Exactly. Yeah, because otherwise you can lose them. Some things that you can do with SNS is if those events are received, and you have like an error inside your code, you can actually signal back that the event wasn't processed correctly, and it can do like you can load it off to different to that ladder queue or something like that. So there's some mechanisms in for handling errors and things happening with those events. But overall, having it together with XQS is a good pattern to use. So if you want to create one using the CLI, you can do just as easy like create topic with the topic name, and then you have something you can publish to and you can create subscribers for. Or you can use CDK and you can say, yeah. Exactly, yeah, yeah. So this is also basically what you can see with the how the pattern will look like. So what you usually see with publishers is that they are also using different topics. So sometimes services can make distinguish between certain events. You can also see it like an anti-pattern because that could also mean that your service is doing too much if you have to publish too much topics. But in this case, you can distinguish US orders from EU orders, make sure that they have their own list of subscribers. For instance, in the US, there are like different VAT handlings and those type of things that need to happen if you look compared to, for instance, EU orders. So maybe different audiences are interested in those events. You can use filters to do it as well for the routing, but yeah, sometimes making a different topic is too. Just like Eventbrite, you can use the filters. So in this case, you can say like, what is the location? And then you can filter on that. And then the subscriber can actually determine which type of events to come in there. It depends a bit on what you want to achieve. If you really want to have them separated out, for instance, if you have a multi-tenant system, one of the things is that you don't want to that you want to have tenant isolation, so you can create topics per tenant, for instance, and you can say like, hey, we really clearly separate them. And it's also about limits and throughput. So if you have a lot of events on this, you can make separations to actually increase throughput of those events. So what actually happens if we want to store events? Because, like I said, if you push an event to SNS or an event store and no one is listening, it's lost, right? And sometimes you want to buffer them. Sometimes there's problems with the service, why it's not listening, and those events can be just as important that you don't want to lose them. So having like an event store in place, like a queue, is something that you can have. Sometimes you also see people using like Kafka or Kinesis, like Stream, as like an event store. You can do that, but there's usually a difference between messages and streams. Messages are usually individual. They tell something on what happened to a certain entity. You can see them loosely from each other, right? Well, a stream is actually a piece of data coming through. And you only see the whole story if you have all those pieces together, like a video image, right? So that's usually a difference that you see with either you choose for a stream or for an event. And also if you want to use Kafka but you see also people using streams for publishing events because you can have different subscribers to streams and you can read like places within the streams, react on those type of things, and it's always there. You can also go back and forward if you want. So streams has some advantages in there as well, but usually they are used for messages that only tell something when they are together. That's also why streams usually are in order. Events can be out of order if you want. So. Okay. So Let's look a bit on like, okay, what type of information can you put in an event? Because it also has some implications in there. So let's say if you have an event that just say, hey, an order with this ID has been created at this time by this customer. It's information that is like, it happened, it's important, and our downstream servers can actually use to that. But it's actually missing also context. It doesn't know what's in that order. It doesn't know who the customer is. And for instance, for an order picking service, yeah, it's important to know which items to pick, right? So you can actually send an event that actually yeah, contains more information, like what is the status, what are the items, what was the price, those type of things. And if you talk about like what should I put in an event, usually you want to have you have to think about like, okay, how does this work? Because you can see it um, like an order has been created, like that's announced. And the person that receive or the service that received that event, what will it actually do with that? It's not that you care too much, of course, because you don't want to tie yourself up to the downstream services as much, but you want to give just as much information that people can actually make sense out of that event and work with it. So, because if you only send like the order ID, of course, the downstream service can reach your API back, like, okay, then give me the order. What are the details in there? But you have to think about that if all those downstream servers constantly have to go to your API asking, like, what is the detail of that order, you might want to put that information into the event because you don't want to give yourself too much pressure from downstream to actually um, um, yeah, to handle those type of requests. So you want to give just as much. You also don't want them make too big because yeah, it also comes with a cost, of course. An event, there are bytes over the network, and then especially in scale, it can add up. So yeah, it's hard to find the sweet spot there, and that's also why it's important to have like different event types and different versions, because then the downstream services can actually decide for themselves how much detail they want and what they want to reach for. To help a bit, like, okay, which type of service do I have to use when I talk about the events? So this is like a decision tree. I will not go to the full set of it, but to give an idea is like, hey, is this event like an IT event with something like the AWS IT message broker? So it's more towards things happening with devices using MQTT and stuff like that. If it's not, okay, then you have to look like, is it something that is a system that is already existing, or is it a new one? Usually new one, we want to use modern application services to do that. So we want to fall into the category of SNS, Eventbrite, SQS. But if there are like existing ones, yeah, you can think about RabbitMQ or Redis or even any other EC2 type of service. You also have to think about, is it a stream or is it just like an event, a message? If it's a stream, we can use Kinesis or MSK, which stands for Managed Kafka. Or we can actually use SNS as a pub sub or a queuing mechanism in front of that. If you're using SQS, you can also choose if first in, first out, so the order of events is important to you. You can also use Vivo queues. So those are, there's limitations in that. But it is a way how you can remain order of the events coming into the queue, if that's required for your application. Okay, so let's look at an example application and let's look how that actually will look like in an event-driven architecture. So we have like our storefront service, which is our e-commerce service. It has a checkout system that receives orders. And we have Eventbrite in between. That is the one that's going to route all those events to my services. And those are like an order management service, an invoice service, fulfillment service, and a notification service. And the notification service is using email notifications or maybe mobile push events. And we actually want to see how this all works out. So when I receive an order, I send it to Eventbrite. Eventbrite will actually take care of the routing to those services that are subscribed to that. And those services are actually getting those events routed to them. In those services, they are processing those events, putting all those business logic that comes with that. And it actually creates new events because invoices are getting generated, orders are getting processed, and also the orders are getting fulfilled. And so this way it actually, there's like a choreography of those services working together even though they don't know things of each other. They're only interested in the things that are happening, and they are using Eventbrite to do that. And this is how they actually do their task and actually provide the functionality that is required. So if you build this like in AWS, if you can see in this example, this is like a full-blown version of that architecture. You can see the different domains. So we have the order service that actually have like an XQS and queue of order created events. It can use orchestration, for instance, to check inventory, create shipment, release shipment, those kind of things. You can have a state store like DynamoDB, or if it's more relational data, you can use things like RDS or any other or time stream data, depending, of course, what the functionality is. And you can see other services as well that can be set up like that. And they are, as you see, Eventbrite or your event mechanism is right in the middle. Be able for those services to know what there is and address to the outside world of what happened. And based on that, you can actually create these entire applications without deploying any servers or just using the code provided in Lambda and services like XQS and Eventbrite. Yeah, so Oom can write you a nice construct that can deploy all that in one go. So by gluing these pieces together, you can actually build these type of applications and modernize application stacks. And also we see what our customers are doing, coming from like EC2 instances and application deployment, like give me Linux, I put an application on that. To like, okay, let's put an event bus in between because we want to do microservices. To building out something like with containers and with Lambda, and actually have those small components working together, building out this entire application. With that, are there any questions or things that you're like to know, or maybe you're working on an event-driven type of architecture and you have a question on that? Please let me know. Or no? Wow. Yeah, I think we can share, and otherwise, I don't know if there's no. No. Yeah. And of course, if you're working on a project and you have those type of questions, you can reach out to your AWS solution architect and he can actually help you with those decisions as well by asking a lot of questions, most likely what you want to achieve and those kind of things, and then select the proposal for the services of how to use that and how that fits into the architecture. Yeah.
I'll be sure to share it with you guys via the email. So if there are any more questions, then I would like to give Vincent a round of applause. And I have also something to thank you guys for speaking at our event.
Oh, great. Thank
so
you.
I got one for you and one for you as well, Owen.
Nice.
So it's time to have a drink, have a chat, and then we'll round up after a bit. So thank you all for coming, and have a great evening.
The sun